Okay, these are some more problems from section P3. And again, we can look over here. We're going to take the cube root now of negative 8. Okay, well, we know that negative 2 times negative 2 times negative 2 is negative 8, so we could just take this as negative 2. Okay, that's easy enough to kind of figure out intuitively. Okay, the cube root of 8 is 2. The cube root of negative 8 is negative 2. A negative times a negative times a negative is a negative. All right? Now, the fourth root of negative 84, we cannot take an even root of a negative number. In other words, I would have 4 negative signs. There's no way I can take 4 negative signs. I can't, I'm going to have four signs, all right? 4 negatives give me a positive, 4 positives give me a positive. There's no way that's going to work. So I can't take an even power or an even root of a negative number. It won't work, so that's not real. That's just like taking the square root of a negative number. It won't work, so it's not real. Okay, number 63. Now, I'm taking an odd index, then that's fine. I can take the odd root. So this is just going to be negative 3. And we did have a rule that says if this is odd, this is just equal to this value. All right? So they kind of cancel. And you can think of this easy enough. Okay? So as long as they're odd, I can take an odd power because I can have it. And just think of it, negative 3 times negative 3 times negative 3 times negative 3 times negative 3. That would work out if I multiplied this out. And then I took the root, it would work. So no problem there. As long as it's odd, it's okay. And we had some rules that refer to that. Okay, number 66. Now we got to do a little bit of work. But 57, 60, and 63 are kind of based upon the rules and your intuitive understanding of that. Okay. So I've got the sixth root of 1 over 64. So remember, we don't want a fraction under the radical, so we break this up by using the sixth root of the quotient as the quotient of the sixth roots. Now, 64 is the same thing as 2 to the sixth. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So that's 2 to the sixth. And the sixth root of 1 is just 1. So that was easy enough to figure out. And remember, if this is even, we just take the value there. We don't have to worry about the sign. If it's positive, no problem. So the sixth root of 2 to the sixth, or the sixth root of 64 is 2. So that's okay. Okay, now I'm taking the cube root of x to the fourth. So again, I need a perfect cube factor. Well, I know that I can break x to the fourth into x to the third times x. And then I can break this up and I can look at this. The cube root of x to the third is what? X. And then I just have left the cube root of x. So I can break that up. Okay, I hope that makes sense. I probably could have put an extra step in here. I could have said that this is the same thing as the cube root of x to the third times the cube root of x. That might be a good intermediate step. So if I break this up, in other words, the cube root of the product is the product of the cube roots, and then this is just going to be x. And then we have this over here. So I hope that makes maybe a little more sense. Okay. Now 72, I did 73 by mistake. So I have to go down here and do 72. Kind of copied the problem down wrong. I was doing these. Here's 72. So I got the cube root of 12 times the cube root of 4. Well, neither of these are perfect cubes, but if I use the fact that the product of the cube roots is the cube root of the product, then I could put these both under the radical. And then I can multiply them and then I'll maybe combine and get a perfect cube. So what's 12 times 4? 48. And then I can break 48 into 8 and 6. And this time I did break it up. This is the same thing as the cube root of 8 times the cube root of 6. Why did I pick 8? Because I know 8 is a perfect cube. What's the cube root of 8? 2. So that comes out, or that simplifies to be 2. And I got 2 times the cube root of 6. So if that makes sense. So that was 72. Okay. And then 75. Okay, this was the 4 times the fifth root of 2 plus 3 times the fifth root of 2. Now again, we're adding, not multiplying. I have to have the same index and the same radicand, which I do. So it's just like 4 things plus 3 things is 7 things. Okay. And then 78. 3 times the cube root of 24 plus 3 times the cube root of 81. So I have the same index, but my radicands aren't the same. But can I simplify these? Well, let's look at perfect cube factors. 2 times 2 is 4 times 2 is 8. So 8's a perfect cube, and 8 goes into 24 3 times. So I simplify that. And then 3 times 3 is 9, times 3 is 27, times 3 is 81. So 27 goes into 81 3 times. Now I'll bring this out. So what's the cube root of 8? 2. So that comes out here. And what's the cube root of 27? 3. That comes out there. Okay? So I hope you can see that. When I simplify that, the cube root of 8 is 2, and the cube root of 27 is 3. And what's 3 times 2? 6. So I've got 6 of these. Let's move this over a little bit more. So I got 6 cube roots of 3 plus 3 cube roots of 3. So now I have the same index and the same radicand. So it's like 6 red apples plus 3 red apples is 9 red apples. Okay? Or 6 cube roots of 3 plus 3 cube roots of 3 is 9 cube roots of 3. Okay? And the last one in this part of P3, the square root of 2 plus the cube root of 8. Well, we can't simplify that, but we can simplify this. We can't add these because they have different indexes. But what's the cube root of 8? 2. So that's about all I can do. I can't add these because I've got square roots of 2 and 2. Okay? So I hope those make sense. And if you need another example, you can look at 73. I worked out 73 there.